What's up, Algebra Squad? Here we go. Lesson 3.3. This is called slope-intercept form. Super, super easy lesson, especially if you thought the ones before were kind of simple as well. All right, so you are now working in your book. No worksheet for this one. You're working in your book. I am going to ask you something. The reason why I get out of the book a lot is because the book gives you way too much. It holds your hand way too much through the process. All right. I always give the analogy of imagine that you are standing next to Steph Curry or some professional sports player and you're just kind of watching them play the sport and you think you're going to learn by just watching them. That's not going to happen. You have to get your hands dirty and get the hand on the ball and actually get to work. So that is what I'm going to ask you today, even though you're working in your book. Try to, as much as possible, keep your eyes on the screen or on the blank parts of your paper, okay? Try to avoid reading all those little steps that the book is giving you because I'd rather you just actually take it in from the video and my words, all right? So page 155, that's where we're working. The first thing I want to get in your brain is something that we've talked about in the past, which is, do you guys remember what makes a line? What are the things that makes a line? Now, whenever you're thinking of that, think linear and non-linear. What makes something linear and non-linear? Hopefully this refreshes your mind. First, we need to have an equation, right? Now, if you were thinking, oh, what makes a line points that are in a perfect straight slope? You're right. But in the sense of the equation part of it, right? So what type of equation will make a line and which ones will not? Obviously, so an equation needs to have an equal sign. We need to have an X, a Y, or both. So we could just have an X, we could just have a Y. Most of the time, we're going to see it with both, right? And lastly, we cannot have an exponent on those variables that is greater than 1, all right? So if I take you really quick to Desmos to show you just a little reminder of what we're doing. So once again, we do need to have an equal sign. Therefore, we do need to have things on the right side and on the left side. So if I were to type here, I don't know, 4 minus, let's put a Y, let's put on the other side, 2.5, and then let's put an X plus 9, okay? So if I zoom out, that makes a line. The reason why is because my X and my Y value do not have an exponent greater than 1. Right now, they have an exponent of just 1. Check it out. If I go ahead and change the exponent of Y to a 2, it goes curved. So if I change it to 1, it's a straight line. Once again, remember that if you don't see the exponent, just like right now the X, you don't see an exponent, that's the same thing as having an exponent of a 1. It is implied to be there. So I'll go ahead and put a power of 2 for the X, so you could see that it changes curved, or any other number greater than 2, for example, the number 23. All right, if we zoom in, you could see that that is not a line. All right, so what is today all about? Today is about grabbing, I'm understanding the equations and how we can move those numbers and variables around in a specific way, which is called slope-intercept form. So I'm just going to type here. I'm just typing something random here. What I'm trying to do is today's lesson is how can we rearrange these numbers, right? Moving them from left to right or right to left and variables so we can put them in something that's called slope-intercept form. So what is slope-intercept form? The reason why it's called slope-intercept form is because this is the format. This right here is the blueprint of how we want our equation to look like. First step, we want Y to be by itself right here. Y, we want it to be isolated by itself on the left side. Then the term that has X, the X term, is going to go right after the equal sign. And lastly, the number that is by itself, if there is a number that is by itself, it'll go last. Now, the reason why this is called slope-intercept form is because when we put it in this format, Y equals mx plus b, this number right here is going to be our slope. And this number right here is going to be our y-intercept, okay? So it's going to be super easy to graph it or understand what the graph looks like if we make the equation look like this. A lot of the times, hopefully you agree with me, that a lot of the times you guys don't really know what the, what the graph looks like if I just give you an equation like this, right? But if I were to make this if I were to turn this into slope-intercept form, I can actually tell you what the graph looks like. For example, I'm going to go ahead and do that right now. Slope-intercept form, if I go back to it, I need y by itself. So if I want to get y by itself, I'm going to take 4 to the other side by subtraction. So it'll look like this. Y equals, I'm just going to leave the 6. I'm going to leave the minus x. And now I took 4 to the other side by subtraction. So it looks like this. Now, let me just show you one more time that this is the same line. Look, you see? I just took 4. What can I do next to make it look like this? Hopefully you could see that my x term is right here, and there's a 6 and a 4 that can combine. These are combinable. So what I'll just do is I'll go ahead and do 6 minus 4. So I'll go ahead and leave the negative xb, and then I'll do 6 minus 4, which gives me positive 2. And look at that. Look where my green line is. Okay? My green line is on top of the original line, and it's in slope-intercept form. Now, I told you that if we put it in slope-intercept form, which I just did, hopefully you can see this right here and this right here, it looks identical. I can tell you what my graph looks like. First, I'm going to put this number right here as a slope that you guys can understand. And remember that slope is rise over run. So we know that the number in front of any variable, if you don't see it, it's a 1. And I can also make that look like a fraction, like a 1 over 1. Now, don't forget, this is still the same line. Even though I put a 1 over 1, this is still the same line, okay? That just means 1. This right here, 1 over 1 just means 1. It's the same thing as if I didn't have it, okay? So just to Steve like that, don't freak out about it. So once again, let me get back to why this is easy to know how this is graphed. This right here, the +2 is your y-intercept, as mentioned here. Your y-intercept is that number right here. Look at it, y-intercept. Remember that this is your y-axis, the line that goes up and down. That's your y-axis. So that's your y-intercept. And now your slope is 1, 1. And it's negative. My line from left to right is going down. So I can keep creating points going down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right. So you could see how I can actually graph this line by just looking at the equation of it. Super simple. Now, if I just went too fast, let's go ahead and get to some problems. Let's start understanding what this is. Let's warm up our engines so you can get your hands dirty on this one. All right. So in your book right now, write the linear equation in slope-intercept form. So it's asking us to write an equation in slope-intercept form for the line with a slope of 4 over 7. So we have a slope of this and a y-intercept of 5. Okay. How do we do that? Well, let's go ahead and remember what is slope-intercept form. Slope-intercept form is, yikes. Let me go ahead and type it because if not, it's going to be a mess. Y equals mx plus b, where my slope is the m number. So I'm going to put 4/7. Let me actually just do it with a marker this time. In red, 4/7. Okay, and that would be x. I'm just color coding it so you understand where everything came from, plus 5. And I put plus 5 because that's a positive 5, and already here it says plus 5. So that's it. That's all there is to it. There's nothing else. We already finished. This right here is the equation of a line that will have a slope of 4 over 7, and it has a y-intercept of 5. Now, go ahead and put that in your book and look while I take you to decimal so you could see it. Look at the line. Let's talk about it. 4 over 7 is a positive number. There's no negative. So you could see that this line is going up, first of all. Next, the first thing you want to look at is this plus 5, okay? The first thing you want to look at is this plus 5. So if I take you back to my origin here, my 0, 0, you could see that the y-intercept is 5. After I tell you that the y-intercept of 5, we can find the next points by doing 4, 7, a rise over run, right? I can do, watch this. From here, I'm going to go up 1, 2, 3, 4, and then to the right 7. 1, 2, 3, 4, 5, 6, 7. Look, I'm at the next point. I can keep doing this forever, and keep finding points on this line. Check it out. So I'm here. I'm going to go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 4 over 7 is the staircase or the slope that creates this line forever and ever. Now, hopefully some of you guys can open up your brain to understand that not only can we build these steps these steps, that 4/7 to the right and up, but we can also do it backwards. We can go down 4 to the left 7. You can also do that as well. Wait, sorry. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. There you go. There's the perfect intersection right there. All right, so let's go ahead and do this one. You can do this on your own. Pause it right now. Check it out. All right, guys. Nothing interesting, crazy here. We go ahead and substitute a -5 for our slope, which is this m variable right here, and 12 for our y-intercept, okay? So if you want to, I'm not going to do this for all of them, but if you want to go ahead and have Desmos open up in a different tab, I encourage you to do so. So this is what the line looks like. You could see that the line intersects the y-axis at 12. So we know that it's 12 because look at it right here. And it has a -5 slope, okay? The line is going downwards, so I could see that it's negative. And the slope, remember that we always like to see slope as a fraction. So to help myself out thinking about this, I can say down 5 to the right 1. Check it out. 1, 2, 3, 4, 5 to the right 1. I'm going to be in a perfect intersection right here. 1, 2, 3, 4, 5 to the right 1, so on and so forth. All right. I'm pretty sure you're understanding this. If you don't, remember to take off your headphones or raise your hand. Call me over. All right. So what do we got going on here? Example number 2. Write 11x minus 4y equals to -2 in slope-intercept form. Okay, hopefully you guys could see that this equation that's given to us right now is not in slope-intercept form. Let me remind you again, what is slope-intercept form? It's this right here. It's where y is by itself and everything else is on the other side. So what do we have to do? Algebra. You already know the math that needs to be done. You have been taught this. So let's go ahead and get started by taking the 11x to the other side because we want the term with an x to the other side by subtraction because this 11x is a positive. So we're going to have a -4y is equal to, look what I'm going to do. A lot of the times, hopefully you guys do understand that these do not subtract. They're not like terms. The 2 does not have an x variable. So what I'm going to do is I'm going to put the term that has the x first, which is my -11. Put that first. I want it to look like this. Okay, I'm going to try to mirror that as much as possible. All right, so I'll put my -11x and then I'll put my -2. My last step is to separate the -4 from the y, meaning take the -4 to the other side. Hopefully you agree that the -4 is multiplying with y. So the inverse operation or the opposite would be to divide it. Whatever you do to one side, do it to the other side. Notice that I'm going to go ahead and do it to each term. I'm going to do it to the -11x and the -2 individually, okay? Whenever you do the opposite, they cancel out, leaving you with y equals. And here's where a lot of students normally freak out because we have fractions, but thanks to slope being an easy to understand fraction, a lot of students take a sigh of relief, okay? So remember, embrace the fraction because the fraction just means rise over run. The first thing we want to look at here is that we have 2 negatives. If you do a negative divided by a negative, that's the same thing as a positive. So I'm actually going to cancel these. I'm going to forget about these negatives. And just also, I know that 11/4 will not simplify to a pretty number. So I'm going to leave it as 11/4. Leave it as a fraction. If your fraction cannot simplify, leave it as that fraction. Because we could see that my line is going to be a rise of 11 and a run of 4, okay? Okay, come on, little circle, get out of there. Okay, and then lastly, negative divided by a negative is a positive. Okay, so I'm going to follow it by a plus, and then 2 divided by 4 is the same thing as 1/2. I'm done. This is it. Okay, this is it. Now, what we can do to check that we did it correctly, hopefully you guys agree with me, is that we can put the original one that was given to us, the 11x minus 4y, which is right here. We can put it on Desmos, and we can put the one that we just made up, which is y equals 11 divided by 4. Let's see. Y equals 11/4 x, and then it said plus 1/2. Plus 1/2. Check it out. I'm going to go ahead and select it and deselect it so you can see it's the same exact line. I just moved things around. And not only do I know that it's supposed to be the same line, but I know I did it correctly because I didn't mess up my math because it became the same exact line as the original one. All right. All right. Pause it right now. Go ahead and take a stab at this next one right here. Here we go. So what I want to do here, I would want to take the 16x to the other side. This is a negative 16x, so I will be adding it to the other side. Inverse operations makes your numbers cancel out, leaving you with a negative 4y is equal to, remember that you want to write your term with the x right at first. It's going to get you into the habit of making sure you know that this is going to be your slope, okay? And then lastly, we move on to taking negative 4 to the other side. I think this is the same number that we had on the other one, which is dividing by negative 4, right? So just divide by negative 4, divide by negative 4, divide by negative 4. Right here on the first one, they cancel out as we are doing the inverse operation. Okay. And then we have, what do we have here? A negative divided by a positive, or a positive divided by a negative. It doesn't matter what you're talking about. If one of these numbers is negative, your answer is going to be negative. 16 divided by 4 is 4. Okay. Lastly, a negative divided by a negative is a positive. 56 divided by 4 should be 14. Let me make sure. 14. Yeah. Okay. Making sure I'm doing less mistakes here. And that's it. This is done with. This is right here my line that is equivalent. It's the same thing as the one that was given to us, but it's in slope intercept form. What that means, it's very easy now to see it as a graph. We are very if we had a blank graph in front of us and they asked us to graph this, we can actually graph this very, very easily. Okay, that's what that means. Because as how it was given to us, that's very difficult to graph. Okay. Let's see. Bada bing, bada boom. Moving on. All right. So here we have a word problem, and let's talk about it. Now, I am going to tell you, let's go ahead and read it, and then I'll tell you exactly what I was going to say. The number of job openings in the United States during a recent year increased by an average of 0.06 million per month since May. Okay, so since May, that's our starting point. In May, there were about 4.61 million job openings in the United States. Write an equation in slope-intercept form to represent the number of job openings in the United States in the month since May. Okay, guys, so I'm going to give you the answers of these fill in the blanks, but once again, I told you that what the book does, if I were to go ahead and read this, I don't know about you guys, but my brain would not follow that. It's easier for me to see it and show you the numbers and kind of just give you a flow of what I was talking about earlier. So they want us to make this. They want us to make that with the information given to us here. So instead of me going down by the fill in the blanks, which I know a lot of your brains won't be able to follow, including mine, I just want to show you how easy it is with just the dumbed down version of my version. All right, so they want us to create an equation that looks like that. The first thing you need to realize is we have a number right here that needs to multiply with x, right? And x, you could see here, where is x given to us? Write an equation so open in form represents the number since May. Okay, so they're not giving us exactly what x is, but what I wanted to say is m is a number. If you remember closely from the ones that we've done before, m right here is the number that multiplies with x, And remember that multiplication is something that repeats itself over and over by addition, right? So what we're trying to look for in here in the words is what is the number that keeps repeating itself, right? What's the number that should be multiplied by something else or is repeating itself? And then there's also a number by itself that doesn't repeat itself. There is just the number. It's called the constant. So we have two different numbers. Hopefully you could see. Let's look at them again. In the recent years, during a recent year increased by an average of this per month. You see? That number right there that I just underlined is happening per month, is repeating per month. That means that would be my M number because M is being multiplied by X. And now we can maybe understand that X should be the number of months. Because if I say 0.06 in 12 months, then that means I'll do this number times 12, right? And then let's see what the other number was given to us and understand why it doesn't repeat. Okay, so, and it says since May, and I said before that May is our starting point. In May, there were about 4.61 million job openings in the United States. So there's nothing really happening there. That's our starting point. And then since May, after May, it keeps increasing by that number that we kept talking about. So this number right here is going to be our starting amount, aka our intercept. So if we put it all together, it should look something like this. The number of job openings in the United States since May. So it starts in May with this number right here, 4.61, and then it keeps going up. It keeps going up this much every month. Does that make sense? That's it. So let's see what the fill in the words here are. Maybe some of you guys will prefer the filling the blanks. You are given that there were 4.61 million job openings in May. So let's go ahead and make X the number of months since May, and Y the number of job openings in millions. Because the number of job openings is 4.61 million when X is 0, meaning when we haven't really counted after May, our y-intercept, or our B, becomes 4.61. And because the number of job openings has increased by this much millions each month, that makes it our slope. That's what keeps repeating. So the equation that we came up with represents the number of job openings in the United States since May. Once again, if this was very tricky because maybe I just spoke too much or maybe there's too many words here, it just comes down to two things. One number and another number. All you have to ask yourself is, this number here multiplies with something else, so it keeps repeating. This one does not. It stays constant. So, by the way, this is supposed to say doesn't. Whoops. So in your story, look to see which number is the one that keeps repeating and which one is the one that just stays by itself. So go ahead and pause it right now, take a stab at this one and see if you can get this. All right, here we go. In the first quarter of 2012, all right, so in 2012, well, they're going by quarters. So 2012 quarter one. There were 183. I'm just putting stuff down. Even though you're probably thinking, whoa, you didn't tell us to do that before. I'm just putting stuff down. Maybe I can paint a different picture in your head. There were 183 million users of popular social media sites in North America. The number of users increased by an average of 9 million per year since 2012 per year. Okay. Write an equation that represents the number of users in millions. Okay, so I don't even know why I did this quarter one, because we're not really going to use we're not using this information right here. They're just saying, okay, so starting from there, 183, every year after that, it keeps increasing this much, right? So that just brings us back to, okay, it says create a slope-intercept form equation, y equals mx plus b. And let's see if it makes sense. The number of users, okay, starts let's talk about the first quarter, starts at 183, the number that does not repeat, but then it goes up, right? It increases, right? Increases. Yeah, it increases. So we're using plus by an average of 9 million per year. 9 million every year. I'm going to go ahead and say that this is users and this is years. And then that's it. That should make sense, right? Because if I tell you, okay, guys, how many users do we have in the in year 2025, even though it hasn't happened? If we were to follow this pattern, how many users will we have in year 2025? Then this is what you're going to do. You're going to go, okay, so in year 2025, years. Oh, actually, how many years after 2012 will that be? Okay, so you would have to say, you would have to do the 20, Jesus Christ, 2012 minus 2025. That gives us a difference of 13. So we're going to go, okay, 13 years have passed. This is what you would want to do. Now, we're not doing this. Understand that this is not what we're doing right now. I'm just trying to make sure for those of you that already understood the problem, how you can take it further. So by solving this right here, we can actually figure out how many users we will have by 2025. Okay. We were done here. So if you got a little bit confused, a little bit, after anything that I said afterwards, don't worry about it. Once again, we were looking for y equals mx plus b, where my m number is the number given to us that repeats. And look at it. That's the word right here. It tells you that it repeats. So we put a 9 here. And then here, this number is pretty much the number we start with. Okay. First quarter should be an indication that we start with that number. Okay. And there you go. That's pretty much it. Don't think of anything else after that if you are having a hard time. All right. Example number 4. Now we're actually graphing it. Okay. So they're not giving us the equation, even though we can write it. Even though, you know what, I'm going to write it. They're saying graph a linear function with a slope that is -3/2 and a y-intercept of 4. So the equation actually looks like this: -3/2 x and then a y-intercept of a +4. That's the equation. So they want me to graph the line that is created by that equation right there. Here are the 3 steps you need to follow. Step number 1, graph the y-intercept. What is the y-intercept? That's your step number 1. Y-intercept is 4. That is the first thing you want to do. So in your y numbers, you need to go to number 1, 2, 3, 4. You need to put a dot right there. That is your y-intercept. I know for a fact that there is a line that is going to cross that dot. I don't know how that line looks like. I don't know. It's going to cross that dot. Okay. So I know there's a dot there. Next. Use the slope to create more points. What is my slope? My slope, aka m, is a -3/2. What does -3/2 tell me? -3/2 tells me that the line that I'm about to make needs to go downwards because it's a negative. Okay. If you're worried about right now, which number does the negative go to? Don't worry about it. Use common sense. We need to do a rise over run of 3/2. Year 3 is the up or down movement. Year 2 is the right and left movement, right or left. So if I decide to go up 1, 2, 3, do you think that I'm going to go to the right 1, 2 and land right here? Do you think my line is supposed to look like this? You tell me. The answer should be no. No, Mr. C, that's a negative slope. Your line should be going downwards. So did I go wrong by saying to start up going 3? No, you can start going up 1, 2, 3. But if you decide to go up 3, that means you have to go to the left 1, 2. What exactly did you do? Well, you gave the negative to the 2 because we decided to go left 2 and up 3. So the 3 was positive in the example that I just did, and the 2 was negative. Okay, so what else can I do? Can I create more points? Heck yeah, I can create more points. From the starting point, I can actually now go down 3, 1, 2, 3, to the right, 1, 2. I can keep doing this. This is a ladder. 1, 2, 3, to the right, 1, 2. And here is my line. Okay. Remember that to make a line, you only need 2 points, but I made a lot more to show you that you can create infinite amount of points. You already know the formula, the ladder, the steps that need to be taken to create it. What's step number 3? That's it. Done. All right. All right. Go ahead and put it to the test. All right, I'm going to go a little bit faster here. Step number 1, you want to graph the y-intercept. The y-intercept is located at 7. Step number 2 is from here, create more points using the slope. Our slope is the number -2. Some of you, if you've got stuck, is because you didn't put a 1 under it. Remember, you always want to look at slope as a fraction because it's rise over run. This is the number that's taking me up or down, and this is the number that's taking me right and left. So the slope is negative. Let's not forget. So my line needs to look like that, going downwards. Okay, from left to right, it's going downwards. So if I decide to go 1, 2 down, that means I need to go to the right one. Again, 1, 2 down to the right one, 1, 2 down to the right one, and my line should look like this. Mr. C, but couldn't you go up 2 to the left one? Yeah, you could, but I don't have enough room in this. Look, so if I'm here at the starting point, can I go up 1, 2 to the left one? I don't have enough room in this graph, but yeah, this is going to go forever. Okay, don't count that out. Hopefully you got that correct. If not, put your headphones down, raise your hand, ask me for help. All right, here we go. Example number 5, graph the linear function. All right, so first step right here is to notice that this is not in the graphable format. Graphable format is when we have it in slope intercept form. Right now it's not. We want to get y by itself, so we can go ahead and look at our slope and our y-intercept, nice and pretty to be graphed, right? So the first thing we want to do here, hopefully we all agree, is take 12 to the other side by subtraction, 12x. Our 12x will cancel out, leaving us now with just -3y. Don't forget that that 3y is negative. I'm going to write 12 or -12x first because I want it in this order. And then I'll write plus 18. All right, so what do we have here? We have the -3, which we want to take to the other side by division. Right now, the steps that I'm saying are going to be a little bit faster, less explanation, because we already explained it. We already walked through it on our first few examples. All right. A negative divided by a negative is a positive. 12 divided by 3 is 4. So that's going to give me x. And 18 divided by 3 would give me 6. But that 3 is negative. Since one of my numbers is negative, my result will be negative. So I'm going to have -6. That's it. I'm done. What is my y-intercept, which is my step 1 of graphing? My y-intercept is the number -6. So I need to start at -6. 1, oh, this is counting by 2. So 1, 2, 3, 4, 5, 6. This right here is my y-intercept. And then my slope, m, is the number 4. Or I could see it as 4/1. 4/1 is a positive number. 4 is a positive number. So that means my line needs to go upwards. I need to make it make sense to go upwards. So if I decide to go up, say, 1, 2, 3, 4. Do you think that I'm going to take this 1 right here to the left? Will it make sense that if I now connect my line like this, does it make sense that my line reading it from left to right is going downwards? No, that doesn't make sense. I said my line needs to go upwards. So if I decide to go up 4, that one jump, I need to take it to the right. So it will land right here. I can go ahead and create more points going up 1, 2, 3, 4 to the right 1. Okay, I'll connect all my points together. And yes, you could keep going and making more points as 1, 2, 3, 4 to the right 1. Okay, hopefully we can all agree that this is a simple idea. It just requires a practice. It's new. So if you think that it's still a little bit difficult, it's not, it's just new. The more you practice on your own and then you check your work after, the easier it's going to get. All right. Example number 6. What do we got? We now have an equation that doesn't have an x. Hopefully, I don't need to explain this one. We've talked about this before. Remember that when we have an y equals to any number in the world, that is actually a horizontal line. Horizontal line. That is where all my y values are equal to 2. Where are my y values equal to 2? Y is kind of like your height, right? This is your y-axis. So my y values are how much am I going up or down? So where is my y always 2? All of this right here, all of these. So that's actually the line that goes like this. This is my y equals 2 line. I'm done. Nothing else to do here. So go ahead and get this one graphed. Pause this sucker. Hopefully you don't need my help. Y'all can do this. All right. Check your work. We done. All right, let's see what we got here. This part of your book right here, I would encourage you to pause it and give this a try. You need to match the graph with the function. You got this. Here we go. All right, so I'm going to start with the easier ones, and then I'll go to the ones that require a little bit more work. So the first one I'm going to go to is my y equals 8 and my y equals -4, because these are just horizontal lines that we just spoke about. So right here, that's my y equals 8. That right there is D. My y equals -4 is another horizontal line, and it's right here. That's the only one. Y equals -4. There is no other that I know of horizontal line, so that is C. The next type of lines I'm going to look for are the ones that are already in slope-intercept form, the ones that I don't really have to do work for to get them into slope-intercept form, which means I'm looking for this one right here. I'm sorry, I can look for this one right here and this one right here. These two are in slope-intercept form. These other two options are not in slope-intercept form. So this one crosses 8. It crosses 8 in the y-intercept. This one crosses -4. But I'm just going to look for, let me look for one, just only one at a time. So I'm going to look for the one that crosses 8 in the y-intercept, and it has this a negative slope. So the line is going downwards, 3/1. Okay, 3/1. So it crosses 8. Oh, I like this one. The line is going downwards. And does it have a 3/1? Let me see. 1, 2, 3/1. No, I'm looking for the line that goes from here to here, and it's a little bit more tilted downwards. All right, so that's not the one I need. Did I miscount? Oh, wait. No. Sorry. Whoops. Do you guys understand that these are counting by 2s? Yeah, so I'm looking right now at my other options, and there's no other option that has a y-intercept of 8. It's okay to make the errors as long as you catch them. And you guys know that sometimes I don't catch them because I'm going way too fast. So as you guys can see, I'm not counting. These lines are counting by 2. So if I go down 3, it'll be 1, 2, 3, and then whoa. 1, 2, 3, 4. Okay. So 1, 2, 3 to the left 1. I should be here. 1, 2, 3, 4, 5, 6. What am I missing? Am I missing anything right now? It's a negative sloping line. 1, 2, 3. Oh, that's what it is. Okay. Are you all looking at it with me? Your Y numbers. And this is great that you guys are seeing me go through the thinking process as well. This is not just something that, oh, this is so easy because Mr. C doesn't make any mistakes on it. Yeah, this is a thinking process. You got to understand, hopefully, let me make sure I look at it once again. The lines that are in my Y value are counting by 2s. So this is 2, 4, 6, 8. The lines that are in my X value are not counting by 2s. They're actually counting by 1s. So 1, 2, 3, 4. So that means that this is the one that I'm looking for, because if I start at 8 and I go down 3, but remember, these are counting by 2, so I got to go in halves. So 1, 2, 3, and I go to the right 1, right? So I'm right here. That is exactly what I need. And then again, 1, 2, 3, and then another 1. Yes, that's it. That's the one I need, where this is B. So this one's a little bit funky because my Y's are counting by 2s, my X's are counting by 1s. Keep an eye out for that. All right, next, I'm going to go ahead and look for the one that has a y-intercept of -4. Now, I have 2 options here. I already put this one as B. Let me make sure I didn't make a boo-boo. Okay. I got 2 options that have a y-intercept of -4, but notice that your slope is positive. So I'm not going to stress counting it right now. I don't want to stress going through the same pain of, oh, what are my y's and x's going by? I have a y-intercept of -4, but a slope of a positive number. This right here is the line that I'm looking for. That's the line that's going up. This line is going down. It's a negative slope. So E is going to be for this one. All right, so let's go ahead and now get this one turned into slope-intercept form. We have 3x minus y equals 8. Take 3 to the other side by subtracting 3x. Now we have negative y. Don't forget that the negative is still there. +4. And now here, this is where a lot of students freak out. How do we get this negative to the other side? The simplest idea, the cheat code is you simply take it to the other side, and everybody to the other side changes their sign. All right, so it's no longer on the left side, and your -3x becomes a 3x, and your +8 actually becomes a -8. Okay, behind the scenes, what happens is that you can either multiply by a -1 or divide by a -1, and that is what changes them to become this. All right, so right now I'm looking for the one that has a -8 y-intercept. We have a -8 y-intercept right here. The other one that would be my choice has a -4 y-intercept. So this is going to be A. Leaving me the last one, F, right here. No work to be done if everything matches 1 to 1. Now I look like a big donkey if that's not true. All right. I believe this is the last question. All right. Yes, it is. This is going to be similar to the question that the first word problem that we did, where we're not really going to be using the fill in the blanks as the book would suggest. Just follow the information that I'm giving you. Hopefully it's going to be simpler than the fill in the blank. Now, the number of online shoppers in the United States can be modeled by the equation blah, 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 where Y represents, okay, so we have Y represents the number of millions of online shoppers. Got it. In the United States, and X is the years after 2010. So 2010 is our starting number. What that means is this right here is 2010. This is 2011, 2012, 13, 14, 15, 16. That's how it means, right? Okay, so after 2010, estimate the number of online shoppers in 2020. So the book takes us here to a crazy journey about graphing all of it, but I am just going to show you how simple it will be to just use the equation to help us. Remember that what we are dealing with is it's a line. We have a line, and it passes the vertical line test. So what's happening is we are starting at this number and we're going up this much. So I'm just going to give you a rough estimate. We're starting at 172 somewhere here. I don't know. I'm just guessing it. And then it's just going up. It's going up from there. Now, this is a function. A function passes a vertical line test. Why am I telling you all this? Because what we're just doing here, other terms to say this is we can actually write our function, our equation that's given to us here in the problem right here as 5.88 every year. That's happening every year after 2010, plus the, I wrote too big. Let me write smaller. So my function is in years, because those are my x's, 5.88 every year plus 172.3. Okay, so how many will we have in 2020? How many will we have in 2020? Now, what you don't want to do here is you don't want to input the number 2020 here. because we're trying to input the number X. And what is X? Take your time, take your time. X are the years after 2010. So how many years after 2010 is this right here? That's 10 years. That's 10 years after. So that is the input that we want to do here. This equation here, this equation tells us how many we're going to have after the year 2010. So if we put, okay, so how many will I have after 10 years? Let's go ahead and do the math. PEMDAS will tell us to multiply first. So 5.88 times 10 is going to give us 58.8 plus 172.3. What do we got? Plus 172.3 should give me 231. Hopefully I'm not making a dookie mistake here. 0.1. Okay. This is the answer. Those of you that are freaking out about, oh my God, what did he just do? It just goes back to a function. Remember, we've done this before. It's a function. You have your input it. The only tricky part is that 10, this number right here, the input wasn't really given to us as a 10. It was given to us as a 10 in disguise. Okay. So let's go ahead and go through the fill in the blanks. Those of you that want to fill up that part in your book. So I can use the slope and y-intercept to graph the function. The y-intercept would be your starting. Oh, I think this is all of it. There it is. So your y-intercept would be the 0,172.3, which means that there were 172.3 million online shoppers in 2010. Like I said, that's the starting point. And your starting point is always your y-intercept. Your y-intercept. The slope is 5.88, which means that's how much we're going to be doing every year. 5.88 million every year. So if we follow that pattern, if we start at 172, for those of you that are like, what? How did we get to this number right here? I didn't get it. Well, we started here, and the story is telling us that it's going up this much every year. So if we were to do this, this is what this right here is 2010, right? And then in 2011, that happened. In 2012, this happened. It keeps going up. So think about what we're going to do. We're going to be doing this right here all the way until 2020, which how many times would that be? How many times would we be doing this? That's 10 times. We're going to be doing 588 10 times. And look at it right here. We're going to be doing 588 10 times, but then we're going to add it to the starting amount. That's how that should all kind of make sense. There it is. All done. Peace out.